We are going to talk about what is the domain of a function in mathematics or in calculus. So we have a function in the form y is equal to f of x. What would be the domain of a function? So domain of a function are all allowable x's. We take x as input variable and y as the output variable. So domain are all input variables for which when you plug those input values, x values in the function, you get y as the real number. So if for some x you don't get, after plugging in the function f of x, if you don't get a real number, so that x will not be allowed. For example, let's talk about the function y is equal to x square. So we want to know what is the domain of y here. So if we have, let's say, x is equal to 1, we get for y as 1. If we take x as 2, we get for y as 4. Even if we take x as some decimal number, so we get y as 0.5 whole square. So what would be the domain in this case? For the function y is equal to x square, it would be 1, 2, 0.5. So these are all allowable x's because for each of these x's, we are getting a real number which is 1, 4, 0.5. So there should not be any real number which I plug in y equal to x square and I don't get a real value so as the output. So I will say that the domain for the function are all real numbers. So any real number that I take and I plug it in the function y equal to x square, I get a real number. So domain are all allowed real values, real numbers. Let's try another example. So in this case, we take the function y is equal to square root x. Now please see this. If I take x equal to 0, I get y square root 0, which is 0. If I take x is equal to 1, I get y as in 1. But if I take x as a negative number, x equal to minus 1, I get y is equal to square root minus 1. In this case, when x was a negative number, I got a complex number. I got a complex output. So when I have x equal to minus 1, we get y is equal to square root minus 1, which is a complex number. So in this case, I will say that x equal to minus 1 should not be a part of domain because this is not allowed. It's not allowable x because this x equal to minus 1 is giving us a complex number. So all those x's are allowed to be a part of domain if the output is, if they give the output as the real number. So the same way, if we take x is equal to, let's say, another negative number, it gives us y equal to square root minus 2, which is again a complex number. So we will say that the domain for the function what are the allowable x's in this case? So all the positive numbers as well as the 0. So I could put this in the form 0 all the way to infinity, and 0 is included, so we are putting the close bracket, and infinity is we are putting an open bracket. So what is the meaning of this? This is the domain. It's all the real numbers including 0 all the way to the positive infinity. For example, let's look at this on a real number line. If the real number line has minus infinity on the extreme left end and plus infinity on the extreme positive end, and in between you have 0, So the allowable access for the function y is equal to square root x in this case are these numbers which I'm highlighting, including 0. So I'm putting a bold dot here just to show that 0 is included. Either we can highlight the domain this on the real number line like this, or we can put this in the form of an interval. So this is also our domain. So x could be taken from here, from the highlighted part, or x could be taken from here, from the interval. Let's look at another example and try to find the domain for the function y is equal to 1 over x. In this case, we have to find all allowable x's, then we will call them as the domain of this function y equal to 1 over x. But immediately we can see that there is one number which is x is equal to 0. When we plug this x is equal to 0, we get y is equal to 1 over 0, and 1 over 0 is undefined. So remember, the deal here is that all those x's will be the part of the domain if we plug those x's in the function y is equal to, let's say here, 1 over x, and we get y as the real number. But in this case, when we plug x equal to 0, we got y as 1 over 0, and 1 over 0 is something undefined because 0 in denominator is not allowed. So by plugging x equal to 0, we got not a real number. So we will say that x equal to 0 should not be the part of the domain. But other than that, if I take any x other than 0, if I take any x like x is equal to 1, x is equal to 2, x is equal to even a fractional number 1 over 2, and in every case I get y as some real number. For x equal to 2, I get y as 1 over 2. For x is equal to 1 over 2, I get y as 2. So I'm getting the real numbers. So I will say that what's the domain of y equal to 1 over x then? The domain, I'm going to put this domain in a very simple way, that the domain is all real numbers in this case, positive, negative, fractional, non-fractional. So all these numbers are the domain, real numbers are the domain, except backslash 4, 0. That's the domain. This is one way of putting the domain. Another way of putting the domain is to highlight this. So we have a real number line from minus infinity to infinity. You have 0 in the middle. So allowable x's are all the numbers on the right of 0, all the numbers on the left of 0. But on 0, since it is not allowed, I am putting an open circle like this. So let's write this part in the form of the interval. So I have highlighted this real number line is showing that x could be taken from these highlighted parts. But now I'm going to write this highlighted part in the form of the intervals. So this left side, left of 0, it's from minus infinity all the way to 0. Since 0 is not included, I'm putting an open bracket. On infinity and minus infinity, there is always an open bracket. So what is the meaning of minus infinity to 0? It's all the numbers in between minus infinity and 0 are the part of the domain. Then this part, right hand side part, this part is written as 0, open bracket, all the way to infinity, meaning all the numbers in between 0 and infinity, and 0 is not included, that's why an open bracket. So this is another way of putting the domain in the form of the interval. This is the domain for the function y equal to 1 over x. We can also talk about another example to find the domain of that function. So let's look at this function y is equal to 1 over x minus 1, x minus 3. So we are going to find the domain of this function. Again, domain is all allowable x's. So allowable x's which don't give us, if we plug those x's and we don't get something undefined and we don't get a complex number, so we will call those x's allowable x's. But if by plugging any number I get something undefined for y, or a complex number for y, so we will not include those x's in the domain. So here we can immediately say that there are two numbers here which when we plug in the place of x's in y, we get something undefined. One is the number x is equal to 1. See what happens when we plug here. We get 1 over 1 minus 1, 1 minus 3 gives us, so this gives us 0, this gives us minus 2, so we get 0. So 1 over 0 is undefined, so 1, by plugging 1 we got y as undefined. So as long as by plugging x values we get y as real numbers, we are good. But if by plugging 1 x we get something undefined or a complex number, that x should not be the part of the domain. So x is equal to 1 made our function y undefined. Also when we plug x is equal to 3, you will see that we get y is equal to 3 minus 1, 2, and 3 minus 3, 0. So again we got y as something undefined. So in this case again we will say that x equal to 3 should not be the part of domain because it gave us an undefined y. So in this case let's put the domain of the function here. It's all the real numbers. We are fine with all the real numbers except for two numbers 1 and 3 because they made the function undefined. Or we could put this domain in the form of interval, but before that we will have to highlight it on a real number line. Here we have the real number line, minus infinity on the extreme left hand, extreme right hand we have infinity, and we have 0 in the middle. So what numbers are not the part of the domain? So 1, which is on the right of 0, and also somewhere here 3. So since 1 and 3 are not the part of the domain, so I'm putting an open circle just to indicate that 1 and 3 are not the part of the domain. But other than 1 and 3, everything, so it's my way of highlighting it. So everything is the part of the domain. So let's put this first of all. This part in the form of the interval, it is from minus infinity all the way to 1. And 1 is not included, so an open bracket. Then this middle part. And we will combine them by using the union. So this part is in between 1 and 3. So all numbers in between 1 and 3, and 1 and 3 open bracket because there is no, and they are not included, union. And then the next part, which is starting from 3 all the way to infinity, meaning all the numbers in between 3 and infinity. So that's the domain of the function here, which is y is equal to 1 over x minus 1, x minus 3. So I'm stopping here, and in the next video don't forget to watch the second part of these domain of the functions. We will discuss a couple of more functions and their domains, and also the operations of the functions and the domain on the operation of those functions. Thanks.